Thank you everyone for listening this podcast. Myself Vishnu VG. I'm a .NET developer working with C# and cloud technologies. I'm from Thiruvananthapuram, Kerala state, which is on the southernmost part of India. I have experience working with different cloud providers like Microsoft Azure, Amazon Web Services. In addition to that, I am a community builder for AWS storage as well. I have a podcast as well as a YouTube channel where I host episodes that are related to programming and cloud concepts. In addition to that, a meetup group is also there. That is Cloud Computing, Coding Talks -Cloud Computing, which is available on Meetup. In case you are interested, please do check out all those. This podcast is available on all leading podcast platforms. Today, we are going to discuss about the microservices architecture with examples from the leading cloud provider AWS or Amazon Web Services. The concepts that you are learning through this podcast equally applies to all other cloud providers as well. As of now, recording date of 24th June 2022, the major three vendors in cloud are, first one is the Amazon Web Services, second one is Microsoft Azure, and third one is GCP. And when organizations develop application with having a lot of teams, each specializing in their own language and capabilities, the microservice architecture is getting very popular because nowadays through the cloud services like AWS, different services are provided by them. So organization can demand some of the services whenever they required for their application development. They can use the service, pay for the service or the time which they are using the service, and then they can entirely shut down that service. So this way, on-demand cloud computing has triggered the microservices mode of development in a rapid way. Even though microservices architecture was there in the earlier times as well, it was not that much popular as of these days because of the main reason for that is the cloud computing. So the cloud is one of the trending topics out these days, and every developer or every aspiring developer needs to be aware of these cloud concepts along with their application developments. That is very critical for better developing their application. If you are dealing with some kind of trivial application for some client, maybe you don't need to invest in cloud. You can create a server in your own infrastructure. Some organizations are still doing that if the application they are developing has not any scope for that kind of scalable or that kind of development. So for trivial application it is fine, but when it comes to the organization level or the MNCs where a lot of companies starts using a lot of companies began developing applications for massive clients. Of course, they expect huge level of scalability. So they consider all these things from the initial stage. So instead of developing a monolithic application, that is the trend that was there in the older times of software development. So in the monolithic concept of development, a single code base is there, and that single code base is developed and deployed entirely. So that is called monolithic, a single code base. To understand that it is very easy, but when it comes to making change or whenever the client requires some change in that application, it will be very hard to deal with such changes because you need to change the entire application at all, and you need to deploy that also all at once. So that prevents the scalability. And also when it comes to the monolithic, you can consider an application having distinct parts where some distinct parts needs to have more computing power or more processing power, and sometimes a specific part of application like a payment part or the display part of the application needs more processing power or more scalability. So with this monolithic mode of development, it would not be possible, because you can only scale the application all at once, or you can scale down the application all at once. You can't have a granular level of control in increasing the scalability on each particular part of application. So that way, different architectures, because of that limitations of monolithic application, different other application models have evolved. Some of them are already discussed in the earlier episodes, where you understood about the three-tier pattern and all. So this is microservices a bit more than that, and this is one of the trending topics out there in these days as of this recording. So understanding about microservices and the way how we can convert a monolithic application to microservices is also very important for an application development. All those concepts we will try to learn through this episode. So feel free to listen this episode. Before starting the episode, I would like to thank Teddy Ariono, who is working with AWS. I attended one of his sessions and learned a lot related to this microservices and all. Some of them are sharing in this podcast. Also, I would suggest you to read one interesting book called Monolith to Microservices by Sam Newman, which is available on O'Reilly Publications. So that book is very interesting, and it provides a great detail on understanding these microservices concept in more detail. This episode will give you enough information to understand about what is microservices. Many of you already familiar what is microservices, as I already covered some of that part in the initial part of this episode. So instead of a monolithic form of application development, we create independently deployable services that work together and modeled around a business domain. So these are the three important part to understand. So one is we develop and develop independently deployable services. So instead of monolith, we develop different services that work together, means they communicate together via a network. So to understand it very easily, maybe you have listened my earlier episode already, maybe you are familiar with what a microservice is, but for those who are initially listening this podcast, for them I will just give a quick brief of what it is. So imagine if you have a website application, you have three parts: the front end, back end, and the database, and you can split these into different services. So that's one example. It need not to be exactly like that, because for a simple web application, that kind of splitting would be an overkill. But if it is a complex application like a shopping cart application, you can have a service for displaying the service for fetching and displaying the different products to the users, and you can have a different service that handles payment and all, that is that payment service. You can have another one service which deals with the shipping of the services called the warehouse service and all. So this way different services can be created, but the important thing, as we understood from the definition, is they work together. These services work together and they are worked around a business domain. So that means you can think of Amazon shopping website as such example. It's actually it can be a microservices. We don't know the exact internal details of how it is made, but we can assume that it would be a kind of a microservice based pattern it's developed, where one service will handle the front end part, and other service will handle the rest of the functionality like the payment, processing of ordered products, then the maybe other service for handling the return and all. So this way different services work together, and each service has no relation with other services other than the communication that is happening through the network. Just a minute. Even though we will be developing independently deployment services that work together, that can be scaled, work together, that can be scaled independently. Each, maybe if there are 3 services, one service can be scaled up and down, and it can be changed as a developer can change that as well, and can be deploy that as well without affecting any of the other services. That means if something problem happens to a shopping website where a payment system needs to be modified, developer can work on that, and that payment service can be deployed independently. So that helps the developers as well as the deployment process as well, because they don't need to bother about the other parts of the application, whether that they don't need to confirm the other parts it is working properly and all. A higher level integration test would be there, but still the level of test that needs to happen and the level of deployment process needs to happen will be much simpler. And in case if some part of the application needs to be modified, that also can be done very easily using by taking advantage of the microservice form of development. So many of the organizations are choosing this form of development for their application, especially if the application have a scope for massive scalability. Many of the clients also prefer that. Then some of the other side advantages that gets from the microservice architecture is by developing this kind of architecture, different teams can work independently on their own services. So maybe a team who is specialized in JavaScript and React applications can focus on the front end part of application. They can work their best to make the front end look attractive and user friendly for the user. And similar way, some other teams who are capable for server side development can work on that part as well. And maybe some other team who is expert in developing web APIs for mobile or the website, they can focus on that API development. So these each can be different services, and different specialized teams can work on their own product without depending on any of the other teams. So these are some of the advantages that they would get, and also there not need to be choose any specific language for the entire application development. If a team is capable of developing a front end using React, they can do that part. And if some API team who is working on the back end or API prefer Python for that API development, they can choose Python for that. These are some of the advantages that a microservices provide over the monolithic form of development. In addition to that, the most important thing is scalability, where each service can be scaled independently and each service can be treated for deployment independently, thus avoid complex overloads and testing difficulties. Now, I hope you understand some of the points where we understood that there will be different services, they will be communicate via other service. So this communication via network is important. This communication can be happen through in most of the cases it can be happen through the REST API. In the previous episode where I was explaining about the microservices architecture, I explained that most of the services will be contacting each other through the REST API. So I would like to clear that some may have a doubt whether only REST API is the only standard that is used for communicating with services. Not like that. It depends upon the teams or the architect who decides how the microservice should interact with each other. They can choose either a other set of standard like gRPC or GraphSQL or WebSocket, or in some form as a kind of asynchronous standard is also used, where they choose a broker or a message queue to communicate with other service. This is important because imagine if two services in microservice want to communicate each other, and like we discussed earlier, microservices provide the capability to scale and deploy independently. So sometimes one service may be down, and at that time if the other service want to contact with this particular service, it may not be possible. So synchronous communication is not a good practice in microservices. It can be there, but you have to, as a developer, you have to understand the entire context, where if there is a possibility for one service to go down for maintenance or for some other purpose, then an asynchronous form of communication via a message broker or the message queue, and the Amazon services provide different services for that purpose, like the SQS, SNS, etc., where you can leverage those services for communicating different services asynchronously. So instead of one service contacts other service directly, they contact via a queue, where they when something they needs to communicate with other, they insert that into the queue, and whoever who is subscribed, whatever other service which is subscribed to this particular queue will get notification, and they can work based on that message. This way asynchronous communication is also possible, but the most easiest form of the communication that can happen between the services is through the REST API, and that would be a kind of a synchronous form of communication, where there's no intermediary like message queue or anything happen, but you need to think about the possibility. We will come to that topic a bit later, where when we think about some of the common pitfalls or some common misunderstandings that can happen when developers develop application using microservices, we will list out all those, and we can understand a bit about those misunderstandings that can usually happen. And when discussing that point, we can think about this asynchronous communication and all those things. Then another important thing is an ideal microservice should have independent database, because that's the way by which the principle of information hiding based on the concept of domain-driven development is implemented. So a properly architected microservice would ideally have a single database for each service. And there would be arguments that a microservice can have a shared database, but that limits the scope of scalability, and the more you bind a shared database with multiple services in microservice, it defeats the purpose of microservice, and it would behave like a kind of a distributed monolith. So as far as possible, reduce the level of coupling between different services. So the terms coupling and cohesion is very important to understand with related to microservice. We have understand the concept of microservices, but The concept of coupling and cohesion also needs to be understood very clearly from the start of application development, or even when before deciding how the microservice application should be. Usually the architects who develop a microservice architecture will prefer a stable microservice architecture where the coupling will be low. So low coupling and high cohesion. Coupling means how changing or modifying one service, one modular service in microservice affects or requires a change in another. So imagine if there are 3 microservices, and if you want to change one microservice, will it requires a change in other service as well? If the change is high, that means there is a high level of coupling or dependency between these two. So that indicates a problem with the architecture. So the better an architect can design an effective microservice architecture, the coupling will be very low. Then the cohesion is another important thing. So coupling and cohesion, these two go related. So the higher the coupling, the lower the cohesion, and lower the coupling, that is what we prefer. When the coupling is lower, the cohesion is higher. So the term cohesion means how we group related code. So the role of architect is to decide and understand how their application they want to be. So they group all the related codes and they identify the service boundaries. So that concept is what we discussed earlier. So whenever they architect an application for microservices, they should identify all the related group of code and they group it together to make it as a service. With the example we discussed before, when it comes to the Amazon Web Service, the payment part is where all the payment related code is cohesed, and we can call that part is includes that cohesion, and that can be considered as a service called the payment service. Similar way, the return or refund of items from Amazon, that can be processed by other service, and all code that is related to that particular part can be grouped together. So in this way, we should identify the entire application related code and group it together, so that ideally when it comes to a proper microservice architecture, the cohesion will be very high. That is, the grouping related code will be very high, and the coupling, that is dependency of one service with related to other service, will be very low. That means once that effective architecture is in place, changing on particular service will require minimal change or no change in the other service. And that should be your ideal when designing a microservice architecture. It's not easy, but that is the required architecture that every client or organization expects from a software architect. So in short, we can say a structure or microservice architecture is stable if the cohesion is high and the coupling is low. Then the other things, we were discussing about some of the general features of the microservice based architecture. So individual database is a must, and that splitting of services to different modular service, that should be modeled around a business domain. So these are based on the level of code that can be grouped together, and by applying the principle of information hiding and identifying the boundaries based on the domain driven design principles. So each domain can be identified and services can be grouped. So ideally the service should be grouped based on the business domain and not based on the skill set that developers have. earlier we understood one of the benefits or the side benefits of the microservice architecture is that the individual teams who is specializing on one particular language or technology can develop their part when developing a microservice architecture. But that is a side advantage or one of the other advantage that an organization gets by adopting a microservice architecture. But that should not be the main factor in deciding or splitting these different services. An architect should split based on the other factors like the business domain considerations, and also based on the principles of domain-driven design, and not based on the skills that individual developers have. This means that they should divide the services initially without considering all of the different language capabilities that their teams have. They can later choose a specific language for doing a particular modular service. That can be decided later, but initially the grouping code or the splitting of code in the microservice architecture should be guided by the business domain and based on the domain-driven principle. Another some of the features as well as some of the considerations that you should be aware of as an architect or a developer when developing microservices architecture is its independent deployability. You should develop an application and split the application to different services based on the DDD principles or the business domain kind of code grouping. But also needs to understand that once we develop these services, we should be able to change a service and we can deploy this change independently. It should be loosely coupled, that it should not be like if I want to deploy one service, I should deploy other service as well. So that indicates a dependency between services. So that's not an ideal microservice architecture. In an ideal architecture, you as a developer or the ops can simply select a service, modify it and deploy it independently, and it will work. And also sometimes, as we understood, sometimes one service may go down, so a synchronous form of communication between the services may not be ideal. So if you expect some services require frequent maintenance or frequent changes, it should be developed in such a way by using an intermediate queue or some other form of asynchronous communication so that they can communicate with each other. Then there should be a contract needs to be established properly to communicate with the different services. As you are aware from the previous talks and also in the beginning of this episode I mentioned some, like the services needs to communicate with each other through the networks. That can be via REST API, that can be via gRPC, or it can be via GraphQL. Whatever kind of methods can be adopted or standards can be adopted, but there should be a well-defined and stable contract that needs to be exist between the services, because each services will be developing by individual teams. So they should have a clear understanding that they will be contacting some services for some other services for some data. It can be a direct communication to some other service, or it can be through a message queue through an asynchronous fashion as well. But that contract or that stable definition of API and its contract should be there. There should not be shouldn't be any confusion with that. Otherwise, if one team who is working on one service changes its API, it affects all the other team as well, because they are working independently. So a proper well-defined stable contracts with a well-divided API, and if there is no backward compatibility that you are planning for your API or your service, make sure all the other teams who are working on the different other services should be aware of it. Otherwise, there will be sudden surprise for the other teams whenever you or your team makes a change in one service, it will affect the other. So proper contract should be there. Second thing is, you should avoid at all cost the database sharing. Database sharing is an anti-pattern in microservices. One of the common reasons that many developers or many people would argue is that they can include the business logic in database, and which can be in the form of either a stored procedure or function, and they can share with other services. This practice is terribly wrong. It defeats the purpose of scalability, especially if you use a system like RDS. RDS is Relational Database Service. In Amazon Web Services, if you look into the portal, they have categorized their services into different categories. So those of you who want a database like a SQL Server or MySQL or the Oracle can go to the RDS section, and they can select a particular database they like for their application development. They can choose either SQL or Oracle or whatever. And many of the application developers who develop application using the RDBMS, Relational Database Management System, or the database that we use for storing transactional data in application, they usually go with a pattern like creating a lot of stored procedure where they include the business logic inside stored procedure. That practice is really bad, and it is one of the challenge happens when migrating an existing monolithic applications to microservice. So when migration happens, the developer needs to extract all the logic that is hidden inside the database stored procedures and share and develop it as modular service. To avoid that kind of problem, if you are developing a new application, don't store any business logic inside stored procedure or function or anything at the database side. Database side, keep it simple. Its purpose is just to store data, get data as fast as possible, and not for storing business logic. Business logic, it should reside with the modular services. It can be inside any of the different modular services that we splitted. So again, again, it will be better to not store any business logic inside database. And if it is a RDBMS, it would be a great problem, because when it comes to the microservice architecture, ideally you should have a different separate database for each service. Otherwise, it would not be an ideal microservice architecture. And there are some cases where you can have a common database, but it's not recommended. Just for your understanding, if you feel that you can use a database and share it among different services, make sure it should be a scalable database like Amazon DynamoDB. It's not an RDBMS, it's a NoSQL database where it is used for storing the user sessions and all in better, and it can handle those users state and sessions better than a relational database, and it's also scalable as well. If you are using such a kind of database which is scalable, it's fine. But RDBMS, it's an old kind of technology. it provides limited scaling only. It can provide vertical scaling as well as scaling in some way through pooling and all, but not to a level that is equivalent to the level of services in microservices, where each service can be independently massively scaled. So database, each database, a separate database should be there. Many application developers prefer to use the RDBMS like SQL Server or the Oracle or MySQL as the de facto standard, but ideally the trend should be like RDBMS can be used, but it can be used for storing the transactional data, and don't use it for sharing between different services. And second thing is like for storing other user related sessions and all, try to use something like NoSQL database. I think we have covered some of the required very important things that are related to microservices. By understanding these things, you can develop a microservice architecture in that way. Because if you are new to microservice architecture and someone in the team is telling that next project we are going to work is developing based on microservice architecture, naturally you will fall into a confusion how it looks like, what is microservice. So microservice symbol, you will be you can understand some of the concept I mentioned earlier. Revisit or listen the first part of this episode again and again, and can understand how some of the characteristics of microservice. In addition to that, you can also go through the book Monoliths to Microservices, and that will also help you to understand some of the features or definitions or distinct features or how a microservice architecture should look like, and then you can develop application. Or if you are working in existing microservice architecture, by understanding these concepts, you can better work on that application. You can very effectively work on that application, and even can fix some of the existing issues that may have happened as a result of bad coding practices. Now the next important thing, or I will define the 8 misunderstandings that can happen when developing the microservice problem. This is not particular to microservice. This is a problem when usually happens when an application development becomes a kind of a distributed mode of computing. A distributed computing is where instead of a single monolith application, you split your code into multiple modules and split it across. It's not exactly microservices, but a similar form of distributed computing where one part of the application process is happening on one server and another on another server and all. So whenever that kind of architecture is in place, there can happen a set of misunderstandings, and based on that misunderstandings, developers proceed with coding, and after some time they realize that their application may not work effectively. Because of this, understanding these misunderstandings or the fallacies of distributed computing is a good read. So you can search in Google about the fallacies of distributed computing, where you will get an idea. Now I will explain one by one or the more important points related to that misunderstandings, and how we can also understand how we can tackle those things when it comes to microservice architecture development. So we have splitted our application, we have selected a proper technology, we have understood that okay, this should be communicated with the proper contract and all, and whatever ways we have understood so far, we have developed our application. But let's take the first misunderstanding. They are mentioning that the network is reliable. So we have our internet, we have the unlimited internet with high speed internet available at our home, and we have that firm conviction in our mind that the internet is stable. Even though occasionally internet goes down, still during the application development we may not think about all those things. But our application may be used by clients will use that from unreliable connection, unreliable networks and all. Because of this, the assumption that the network will be reliable or network is reliable is a kind of a misunderstanding. And related to network, there are some other things like latency, bandwidth capability, bandwidth will be limited. Then so we can take the first three things. So the first one is the network is reliable. That is one misunderstanding we usually have when developing applications. Second one is latency is zero. Like we expect that those who are using this application will have a high speed unlimited internet where latency is zero. Usually this may not be true, because at some time or some point of time these issues can arise even in high speed areas where some problem happens and the network goes down or its speed goes down. Usually during that time, if someone is using your application and if you not consider all these facts in mind, it will be a problem and they will blame your application. To avoid this kind of problem, different patterns can be used, like the retry pattern or the circuit breaker pattern. I will cover a different episode for explaining all those things. In short, retry pattern is simple to understand. Like if your service is contacting some other service, and if there is no return coming from that service, it should retry 1 or 2 times. We cannot expect that retry to happen indefinitely, because imagine if that service is down and if you are not relying on any form of asynchronous communication pattern like a queue or broker, then indefinitely the service will try to get something from the other service, and it goes like an infinite loop. To avoid that, retry should be there with a circuit breaker pattern. Like after some point of time, it should fail and it should try only after some time. So that kind of mechanism should be there. Second thing is, we assume that users have bandwidth indefinite, or their network structure is this way or that way, and we don't think about compressing before uploading to S3 or something other, some other storage services. All those factors we should be aware of. So before we uploading some file or using some file from some other service, we should think about how much impact that file transfer is going to make. Will it work properly in load transfer system? Will there be proper streaming based download is there, or an asynchronous download pattern is there, or something like that. So whenever a communication is happening other than the normal kind of JSON or gRPC level of communication is happening, we should be aware of all this, like how much bandwidth that is going to consume, how much time it will take on service to download on particular file from other service and all. So or from a different storage area. In addition to that, we can also consider, like if we upload a file, simply a file to the storage area like S3, Amazon S3, usually S3 have an unlimited bandwidth, but what about if the budget is limited and the storage cost goes high? That will be a problem. As an application developer, we should aware of all those things. So the understanding about the 8 fallacies of distributed computing, and if you relate that with the microservice architecture, it will be a good thing by which you can eliminate some of the mistakes that can happen for a microservice architecture. So consider that when developing the application. Then the second thing is whenever then the other thing. So that misunderstanding part is now over. Next we will think about how we can organize the teams in an organization. That part is also very important to consider. Suppose if you have a team that is developing, if your organization has a set of teams that are working on different services with related to microservices architecture, they should communicate with each other. And they should also have communication with the actual customers as well. In the usual in an usual typical IT organization, we can see a kind of silo based structure where technical leadership will be handling by one particular team. So there will be a technical leadership team like the CTO or CIO who is contacting the management or the project management people, and that project management people is responsible to deal with the development team or delivery team, and they will develop and deliver the application. So that technical leadership part is one part of the organization. They remain as an independent silo. And similar way, there will be other section of the organization where a product owner team is actually dealing with the customers. They work as an other silo. So this technical leadership and product owner will communicate each other, but at times only, like if there is some change happens, change required from client requirement or something, usually customers contact the product owner and they will contact the technical leadership, and then the technical leadership will delegate that to the management, and then to management means the project management, and then to the different development and delivery teams. So there is a so here the customers are directly contacting the product owners, and product owners is actually understanding what the client needs, and then they will communicate that to the technical leadership. There is a major challenge with this kind of the structure, because sometimes the product owners may not be competent enough to understand all the technical challenges and all, and how much time it will be required for one service to deliver and all. So what they feel is they will understand something based on their own understanding. They may not have that kind of technical ability like the other technical teams have. So they will come to a conclusion. They can have a discussion with technical leadership as well, but in most of the case they will come to a conclusion based on their understanding, and they may not able to correctly understand the requirement properly, which can be detrimental to microservice form of development. This can be a problem not only for microservice form of development, microservice architecture form of development, but also can be for other kind of application development models as well. But in this microservice architecture where different teams are working in different services, this will be a major problem. So we should break that silo model, and we should instead of that we should split, like the customer should be able to directly contact the delivery team or the development team. Maybe some person who is responsible for that interaction can be arranged, and the customer should be able to directly communicate with the delivery team as well as to product owner, and then they can have a supporting technical leadership team as well. So this way the communication is happening from the customer directly to the delivery team or the technical leadership, and not via the product owner. So this can be helpful. This is called as a technology company structure, where some of the organizations are following this kind of thing. So it breaks the kind of silo model where the product owner is the only person who is interacting with the client and capturing requirements and then conveying that to the delivery or development or technical leadership teams. So instead of that, here the customers are directly contacting the delivery team as well as the product owner team, and they can have a supporting leadership team as well. Now we have understood the concept of microservices, but splitting a application into too many services may not be an effective strategy for some of the organization. So monolith has some advantages where it can group some of the codes there, and microservice has its own advantages. So some of the organization, one example is Shopify, SHOPIFI. If you search in Google Shopify space deconstructing monolith designing software maximizes developer productivity, or you can search like this: Shopify SHOPIFI space modular monolith. Then you would get a blog where they mention how they use the approach similar to microservices, but it's called modular monolith instead of microservice. So in the episode we are discussing about microservice, but mentioning this part is also important, where if you there is a way by which we can develop a kind of a different kind of microservice architecture called the modular monolith, which can maximize productivity according to Shopify. So if you go through that blog, you can understand some of the advantages they would get, and they are mentioning they would get the benefits from both the microservices as well as from the modular world. So if you search for that, you will get an understanding. Shopify modular monolith. So they have written a blog where how it is used. But our discussion is the modular services or microservices. Just I mentioned this point here because when I attended that session, he mentioned this point, so I would like to convey this with you, so you can have an understanding of that. And also another important point, it's worth to consider is always possible avoid the distributed monolith. So distributed monolith means it looks like having a application with multiple services, but there is a tight dependency between each services, so that whenever the services are to be deployed, it should be deployed together. Such a system is called the distributed monolith, and we should avoid this because that system is developed with not focus on that information hiding, and there is no proper boundary that is established between services by grouping related code and all. And because of that, that application became a distributed monolith instead of the modular monolith, that which we discussed earlier. And we should avoid the distributed monolith at all cost, because it will create a lot of problems at the later stage of application development. Then another common problem that many developers hear, or when migrating existing applications to the microservice architecture, is how we deal with some of the third-party black box systems. So third-party black box systems includes some of the existing payroll systems, then CRM systems, then some organization have an existing HR systems, then like this Magento, WordPress, and the SAP, etc. So how we integrate all those things into our existing microservices or the planned microservice architecture. It can be some form of not just this black box system. It can be some other system like the SaaS, software as a service model, like the Gmail or the Office 365 or whatever, some kind of systems, existing systems may be used by the organization. And how can we capture the information from all those, because those all things are not in our control. So how we deal with those things? So one answer to that thing when it comes to microservice migration for those systems is, if there is a possibility for us to identify the APIs, underlying APIs that are related to those black box systems, then we can identify that and deconstruct or decompose into a different service and all. But sometimes it is not possible, like it may be a third-party black box system. In that case, adopting a pattern like backend for the frontend can be adopted. It's very easy to understand, backend for the frontend or BFF. If you search for BFF, you would get the answer. So backend for the frontend is a pattern where we aggregate all the different backend related services. It can be API or it can be an output from these different systems. So somehow we should capture all those and we should aggregate that and we should return that to whatever other services. Maybe it can be a web or mobile. So that is the reason why backend to frontend. So it means that that pattern will have, if you imagine that particular pattern, its left side will be the web and the mobile, and it will be on the middle side we can see the aggregation, and on the right side we can see those different third-party black box systems or whatever other forms of get APIs or all those things that we can consider. This BFF pattern can also be used when we develop the dashboards. Sometimes we want to aggregate the information from multiple systems, especially in this case of microservices where we need to track what is happening in these different systems. So there should be a capturing of information from these different services that are running behind the scene, and we should capture all the information from there. So this BFF or backend to frontend framework can be used there, and then we can aggregate all those things and then can be convey that thing to whatever client or frontend it is required. So it looks like an aggregation. Sometimes we can directly collect the data and can be passed to the frontend, but sometimes the collecting the data from the frontend collecting the data from the different backend systems may require some time. So it's not possible to collect that in a real time. So we need to resort to either some real-time systems or some form of way by which we collect the data, we store there somewhere ideally, possibly maybe in a different database, and then we can return that to the whatever client that is required. This is useful for displaying dashboards and all. Backend to the front end is the thing which we should consider when we want to aggregate the information from different multiple systems. That needs to show to the front end, or that needs to be communicated to the different other services. This can be also used. This BFF can be also used when we deal with the black box systems like the WordPress or some kind of software as a service system where we want to capture the data and we want to present that data to some other service. Okay, so that's all about the backend to the front end. I hope you understand how to deal with the black box systems and also how to aggregate the data from different services when there is a requirement to show that on the dashboard. The dashboard is a mandatory thing that I felt for different microservices, because together as an application we need to understand whatever is happening in different systems. A proper capture of information from these different microservices and to be presented that to the user in form of dashboard, or whoever person who is responsible for using the application will be an ideal thing to include. It may not be a mandatory thing, but sometimes it will be useful. Now coming to the other challenge that faced with the microservices architecture development is the concept of coupling. In the beginning of session we understood like the coupling should be low and the cohesion should be high. Cohesion means the grouping of code, and the coupling means the dependency of one service with the other service. So it can be other forms of coupling as well, and some of the other forms of coupling which also we need to avoid when developing microservice architecture. One such coupling is the implementation coupling. It can be understood like in the case of a shopping website where we usually see recommendations on Amazon. We can assume that there will be a recommendation service that is responsible for understanding the recommendations. So one common pitfall or misunderstanding that can happen for a recommendation service development team, or whoever who is specializing in that particular microservice, is they will be directly contacting the database and they will be capturing the order as well as the customer information, and then they create a recommendation. So instead of that, the better way is to create a separate API which capture the data from that order part only. So whenever an order is happen, that will be captured somewhere, and from that order API, some order API or wherever that order is stored, it can be in a relational database, or it can be in some other database like a NoSQL. It depends upon the implementation, and the recommendation engine or the recommendation service should contact that order area via an API called the order API, and through that way only they should fetch the order information. So this means there is no tight coupling between the recommendation system and the database or the order system. So in between there is an API there. This way implementation coupling can be avoided. Implementation coupling is one of the problem or anti-pattern that can happen. Then the other problem is temporal coupling that can happen. So this happens when, imagine, three of the different services in a shopping is working, in a shopping site is working. For example, there may be a warehouse service which should be responsible for understanding what all items are there in the warehouse, and there can be another service called the order service which gets the order from that warehouse service, and there can be another service called the customer which get there can be another customer which gets the order related information after the order is processed. So different services like the warehouse order or the customer related services can be there for a shopping based application. This is just an example. Assumption is what we are discussing now. Imagine if there are three services like warehouse, order and customer, and each one have an SLA of 0.99. But because of the delay that can happen between these three different services, the SLA can be 0.97 only. because one service is calling the other service synchronously. So there can be a possibility like sometimes a failure can happen. So we can't expect the 0.99 level of SLA, even though the warehouse and the order service have that kind of SLA. So even if the three different services that are involved in processing an entire order, including the warehouse, order service as well as the customer service, aggregate of all, even if they have 0.99 SLA, that's a good SLA, but still we can't provide that to the final product, because that at some point of time maybe either one of these service can fail and the total SLA can be 0.97 only. This would not meet the compliance requirement of the organization. To prevent that, introducing a message broker or message queue or kind of an asynchronous pattern in between these different services will be ideal, so that the even if one service fails, still when it gets active, we can confirm that we can still establish the 0.99 SLA there. When it comes to the compliance requirement and to establish the compliance requirement and to maintain it properly, keeping that in this example it's 9.99, we can have an pattern called the asynchronous communication pattern through the message broker or message queue that can be introduced in between these services, rather than they directly interact with each other. Other form of coupling that we can consider to avoid is the deployment coupling, where whenever one service is deploying, it needs to depend on other services and their deployment as well. This usually happens when a service needs to build, it should get a DLL from some other services. So we should break all those anti-patterns, and we should try as far as possible to develop the microservice in such a way that it should not depend on other services DLL or other dependencies or anything. Whenever a service needs to be deployed, it should be developed and configured in such a way that it should be able to deploy independently without depending on any of the other services. Then finally, the thing is domain coupling. So this is like domain coupling. How we can understand is to understand by taking an example of a shopping website, where imagine there are three different services and a single database is there. Ideally there should not be a single database, but it should have its own distinct database. So but for understanding this example, let's keep it simple. Like imagine there is an order processing service, then there is a warehouse service, and then there is a customer service. So the warehouse service, which is responsible for delivering the different identifying and returning that information to the customer service, should somehow contact the order processing to get the customer details and all. So instead of getting full list of customer details, they should get only the required details. So there can be a separate data part that can be created called the pick instruction, where the whenever a customer is ordered an information, order a product, then that customer details and that customer's delivery address and all, that all can be combined and can be saved into a different area, so that this warehouse or the other responsible service who is responsible for delivering this particular order can contact that data part and get the detail, and then can be delivered accordingly, rather than it directly contacts the order processing information. So the domain in microservices, we split the services based on domain, and it should not have a direct dependency between each other. So instead of when an order processing has happened or it's in progress, then it should create a separate area where it will mark all the required customer and their delivery information or the other information that is required for delivery, and that information can be consumed by other services for their purpose instead of directly having contact with each service. So once a service, the idea is simple. Once a service like the order processing has got an order from the customer, it can mark that data, like the customer data and the order details and all, to a separate area, and the rest of and that is done. Then the order processing can work on the other order and all. But whenever a warehouse service required some information, it can get it that from the place where the order processing has stored the data. So this way there is no direct communication that is happening between these things. Then the other we can extend this to one more enhancement, like instead of getting that detail, that warehouse or the customer or service getting detail from that data store, it can be stored into a queue or somewhere where it is where whenever a event or some data is inserted into that message broker or queue, it will be get notified by other subscribed services like the warehouse service or the order service, and that way we can minimize the coupling. So this is these things are the more important things we need to understand. So we need to, you can search in Google more about that, like we should avoid the different types of coupling between the services, and going into more detail, coupling like the implementation coupling, then the temporal coupling where one service is depending on other, and the total SLA will be reduced further. To avoid that, we can introduce a message broker in between, and also the deployment coupling where one deployment should not depend on other deployment. Also the domain coupling where one microservice should not depend on other service directly, but it should be depend the data from some other area like a message broker or a queue. In this way we can understand the different dependencies, and throughout the episode, so now it's like 1 hour and more, so I feel we can wind up this episode here, and I will come up with a second episode as well that explains how we can migrate the microservices, and also it's a follow-up of this episode. So you can listen to this episode first and then that episode to get an understanding of how you can migrate an existing microservice a monolith service to a microservice architecture. As we are running out of time for this episode, ideally an episode, many listeners would say it's preferable to keep it within 1 hour, so I prefer to cut it down here and resume it from the next episode. So thank you everyone for listening this episode. All the opinions that I share through this podcast are purely my personal opinion. Myself, Vishnu Viji. I am from I'm a .NET programmer from Thiruvananthapuram. So feel free to listen any of the episodes that are available from my podcast as well as from my YouTube channel. Thank you once again for listening. We will keep continuing how to understand more about the microservices with related to the AWS services, and next episode we will understand how we can migrate an existing monolith application to microservices. So thank you very much.